when we have an appliance in our house and we need to get power to it, we have to do a little bit of planning. And in that planning, what we need to do is figure out how much of a load it is going to need and use, and in order to get us the right size breaker. And that breaker will dictate the size of the wire we're going to use. And it's very simple to do, and all the information can be found on usually like a little placard that's in the device, the appliance, whether it's a microwave or an oven or a clothes dryer or a washing machine. So you have to look at that, calculate the load, and then determine the breaker, and then select the wire, and away you go. It's that easy. When you're calculating a load, what you're doing is figuring out how much amp draw there's going to be on by the appliance on the electrical system. So you need to know how many amps, and we have something called Ohm's law, and it's the relationship between amps, volts, and ohms. There's these letters I, E, and R. I being current, E being the force of the electricity, R is the resistance, and the values that are used are amps, volts, and ohms. So we also have something additional which you've probably heard of, watts, like how many watts a light bulb is. That's how much power it's using, and that's usually, the scientific way of looking at this would be the P. So you have I, E, R, and P, and so this is Ohm's law, and it's showing that relationship. And this is different ways we can arrange Ohm's law and get the desired value that we want. And when we use Ohm's law, and it also shows the relationship to power, when we can rearrange it to where amps is equal to watts divided by volts. And that's something we're going to be using quite a bit of, because we want to know how many amps are going to be consumed by the appliance. That way we can find out how big a circuit breaker, because circuit breakers are listed for a certain amount of amps. So we're primarily going to be using this formula to figure out how many amps we need to accommodate. From the power company, we're going to be supplied with 2 legs of 120 coming into our house. The little wires coming into our house. We have 2 of them at 120, and it goes into our panel, our breaker box, and total we can use up 200 amps. And inside there you'll get each one of those service feeders are going to be 120 volts. So we could have appliances that utilize both lines, both feeder lines, and that would be 240 volts, or we could just use one of them, and that'd be 120. This 900 watt microwave, if you look in there, it'll tell you it's using 900 watts, and it will tell you it's 120 volt. So we're going to use this formula. We need to know amps, and we have the watts, and we know the volts of 120, and we need to know what that is. So we will just take our calculator. We're going to take 900 divided by 120, and that's 7.5. So this microwave is going to use 7.5 amps. Okay, so we've calculated how much amp draw this microwave is going to have. It's going to have 7.5 amps. So one thing you need to be aware of when you're selecting your breaker, you need to design it, that circuit, to only handle 80% of that load. The breaker should trip not when it's at full capacity, but before it hits full capacity. So a 15 amp breaker, if we take 80% of that, which all you gotta do is take 0.8 times 15, and that gives you 12. So you really only need to be designing that circuit to handle 12 amps. So a 20 amp would take 16, and so on, and you can do all the calculations yourself. But you need to keep in mind, if you're going to have 7.5 amps, what size of breaker could you use? You're more than okay to use a 15 amp breaker, and because it's going to carry the 12 amps you've calculated that microwave to draw. So we're going to use a 15 amp breaker. Okay, if you have a 15 amp breaker, you cannot use too small of wire. And what will happen is so much electricity will be running through that wire, it will overheat. So you have to have a big enough, large enough conductors so that it will not overheat and it can handle the load that's put on it. So a 15 amp breaker, if you're going to use that size of breaker, it's sized for a certain amount of amps to be running through it. So it needs to be at least a 14 gauge wire, and for a 20 amp breaker, 12 gauge wire, and so on, all the way down to a 40 amp breaker, you'll have 8 gauge wire. So our circuit here with this microwave at 900 watts, it's drawing 7.5 amps. We're going to use a 15 amp breaker, so that means we are going to use a 14 gauge wire. This is a very specific example. It's for this exact microwave. I looked up that microwave and saw that it was 900 watts. That's how much power it's consuming. If we ever change the microwave, this is all going to change. And also, something that might change is I looked it up online, and that's what it said online. But the card on the microwave itself said, it told us how many amps it was going to draw, and it said 13. So that is different than what I got. And what we need to do is go ahead and go with what it says on that card, and we are going to plan for a 13 amp load. So that means 13 amp. So we're going to not use a 15 amp breaker. We're going to go to a 20 amp breaker, and we'll then use the 12 gauge wire. So it all changes. And something else you need to be aware of is microwaves are an appliance that's easy to change. So maybe you should plan for a very large draw on that large load on that microwave circuit. So go ahead and plan for future expansion, if you'd call that, or upgrades. So don't plan for a small, really efficient microwave. Let's plan for the worst case scenario and plan for a microwave that's possibly going to draw lots of amps later. And that way we don't have to go in and change the wiring to supply the electricity to that microwave. And also something to keep in mind is we are driven by the NEC, and it is the codes, I think it's the 2009 NEC is what we use, and those codes change, and every so many years they put out new codes. We have to be aware of those codes and how they've changed, and we will then adjust these things appropriately. The breakers we select based on the code, and the wires we select based on the code. So you have to be up to date with what the code requirements are, and we will make adjustments accordingly.